we are doing the integration of 0 to pi by 2 cos square x dx. We know the property of definite integral. I am assuming this as I. We know the property of definite integral, that 0 to a fx dx. Here x may be replaced as f a minus x, a from the limit into dx. This is the property of definite integral here. So I am applying this property in equation number 1. So I will be replacing x with pi by 2 minus x dx. And this is I. So cos pi by 2 minus x we know is sine, because when pi by 2 is here, it changes to sine. So it is sine square x dx is equals to I. This is equation number 2. Now adding first and second. When I add I plus I will become 2I, and limit is same, 0 to pi by 2, and we can have cos square x plus sine square x dx. And we know this identity, 0 to pi by 2 cos square x plus sine square x as 1. This is equals to 2I. Integral of dx is x by putting the limit 0 to pi by 2, and this is equals to twice of I. So it will be pi by 2 minus 0, that means pi by 2 is equals to twice of I. So I is equals to pi upon 4. This is our answer. Let us assume this as I. We know the property of definite integral 0 to pi by 2 fx dx is equals to 0 to pi by 2 f pi by 2 minus x dx. So this is the property. If in place of pi by 2 any other value is there, any constant is there, so we can have that in the property. So when I apply the property and replacing every x present here with pi by 2 minus x, this is square root sine pi by 2 minus x plus square root cos pi by 2 minus x dx. This is equals to I. Now we know sine pi by 2 minus x is cos x. Again, this is cos x plus this will be sin x. Cos pi by 2 minus x is sin x is equals to I. Let it be equation 1 and this be equation 2. If I add first and second, so I will get 2I. Limit is same, 0 to pi by 2. We have the same denominator. This denominator is same here. So we can have the LCM as root cos x plus root sin x. And numerators will be added. This will be root sin x plus root cos x dx. This term and this term is going to cancel. So 2I is equals to 0 to pi by 2 dx. So integration of dx is x, putting the limit 0 to pi by 2. So when we put the limit, it will be pi by 2 minus 0 means pi by 2. So the answer comes out to be pi by 4. Here we will use the property of definite integral 0 to a fx dx is equals to 0 to a f a minus x dx. So before solving the question, just give a few moments of thinking what I can do, what property I can apply here. So I is equals to 0 to pi by 2. Every x I am going to replace with pi by 2 minus x. So it will be pi by 2 minus x. Similarly in denominator, This will also be sine power 3 by 2 into pi by 2 minus 6 plus cos power 3 by 2 into pi by 2 minus 6. Let it be equation number 2. And here sine pi by 2 minus 6 cos pi by 2 minus 6 will become, this is cos power 3 by 2 x dx. This is sine power 3 by 2 x. This is cos power 3 by 2 x dx. Now adding first and second, I will get I plus I 2i, and this will be 0 to pi by 2, and the LCM is same, sine power 3 by 2x plus cos power 3 by 2, दोनों का base same है. So and the numerators will be added. This will be sine power 3 by 2x plus cos power 3 by 2x. This and this are going to cancel. So I have 2i is equals to 0 to pi by 2 integral dx. तो previous question की तरह it will be x and the limit 0 to pi by 2. So I comes out to be pi by 4. Question number 4, question number 1, 2 and 3 की तरह है. So let us directly take question number 5 here. Here in this question we can see there is a modulus function x plus 2. For modulus function we usually apply this property. That means in between a and b we are getting a number c, and we are splitting the limit into two parts. The first limit is from a to c. First is a, then next is c, next is from c to b, right? So we can apply this property in modulus functions. So here if I put x plus 2 is equals to 0, we get x is equals to minus 2, right? So here it is minus 5 to minus 2, and then minus 2 to 5, minus 5 to minus 2, and minus 2 to 5, because in between minus 5 and 5 I got the value 2, minus 2. So first limit I am taking this, second limit I am taking this as per the formula. So on the right side the function will be positive, and on the left side the function will be negative, because if I put any value between minus 5 and minus 2 in the function, suppose I put minus 3 in place of x, so minus 3 plus 2, this value is minus 1, that means negative, so this value will be negative. And if I put, suppose minus 2 to 5, I put 0 in place of x, I'm getting a 2 as the answer, that is a positive value, so this side it is positive. Very important point to understand. Or to just get the positive or negative sign, just put any value from this interval in the function. If you get a positive answer, sign will be positive. If you get a negative answer, sign will be negative. But normally in these modulus functions, right side is always positive and left side is always negative in maximum cases. Now if I integrate, minus integration of x is x square upon में 2, the limit is minus 5 to minus 2 plus 2, यहाँ पर x हो जाएगा minus 5 to minus 2, then integration of x is x square upon में 2, the limit is minus 2 to 5 plus 2 x, limit is minus 2 to 5, like this. Now we will solve it. So here we have minus sign, keeping minus as it is, minus 2 square, it is 4, then minus 5 square is 25 upon में 2 plus 2 into minus 2 minus 5. This is the first value जो हमने put की यहाँ पर. उसके बाद हम यहाँ पे वैल्यू पुट कर रहे हैं, प्लस दिस इज 25 minus 4 upon में 2 plus 2 into 5 minus 2. Now on solving this value will be minus 4 minus 25 is minus 21 upon में 2 plus 2 minus 2 plus 5, it will be 3 plus 3. Then plus, this is 21 upon my 2. 5 plus 2, 7. 7 into 2, 14. So this will be 21 upon 2 minus 6 plus 21 upon 2 plus 14. So 14 minus 6 is 8 and 21 upon 2 is twice. This is 21. So answer is 29 units. In the same way, question 6 can be done. So let us now take question number 7. In this way, we can apply in this question, we have here the power n, which is creating problem in the direct integration. Let us first remove this whole power n. So what I can do, I can apply the property which I have written here, 0 to a fx dx. I am replacing x with a minus x in the function. So here also I am doing the same thing. I am applying the property and replacing x with 1 minus x at both the places, here also and here also x is going to be replaced with 1 minus x. Always remember, when you are replacing a single value with single term with the value with double term, always put it inside the bracket so as to avoid the mistake of negative sign, right? So it is this. Now I is 0 to 1, 1 minus x. Now if I open the bracket, 1 and 1 will cancel. It will be only x power n dx. The question was this. But after applying the property, question is this, which is very easy to integrate now as compared to earlier. This is x power n dx minus 0 to 1. This is x power n plus 1 dx. Now integrating. So I is equals to, the integration of x power n is x power n plus 1 upon n plus 1. The limit is 0 to 1. Then minus x power, again increasing the power and divide with the increased power. And here also the limit is 0 to 1. If I put 1 in place of x, it will be 1. So it is 1 upon n plus 1. Because अगर मैं 1 put करूंगी तो 1 आ जाएगा, minus 0 put करूंगी तो 0 आ जाएगा. Similarly, here also it will become 1 upon n plus 2. Because if I put 1 in place of x, it will be 1 only, minus 0. Now on taking the LCM, it will be n plus 1 into n plus 2. Now it is n plus 2 minus n minus 1. So n and n cancel. This is 1 upon n plus 1 into n plus 2. This is the answer for this question. Very important question this is. Here we have log 1 plus tan x. As it is, I can't do the integration. So let me just try to apply the property by replacing x with pi by 4 minus x. So I'm replacing x with pi by 4 minus x. So it will be 0 to pi by 4. And this is log 1 plus tan pi by 4 minus x into dx. Now here, this is I. So I is equals to 0 to pi by 4 log 1 plus, I know the formula tan A minus B, which is tan A minus tan B upon 1 plus tan A into tan B into dx. So I is equals to 0 to pi by 4 log 1 plus, we know tan pi by 4 is 1. So 1 minus tan x upon 1 plus tan x dx. So I is equals to 0 to pi by 4. Now taking the LCM inside, this is 1 plus tan x. So here 1 plus tan x plus 1 minus tan x. Now tan x and tan x will cancel. So this is I is equals to 0 to pi by 4. This is log 2 upon 1 plus 10x. The properties of log are very important in integration. So here log a upon b, we have the property log a minus log b. So I will write it as log 2 dx minus 0 to pi by 4 log 1 plus 10x dx. So here I is equals to, see, log 2 is constant. So it will not be integrated, it will come outside because log 2 is constant. So integration of dx is x and the limit is 0 to pi by 4. If you look at this carefully, this is the same value from where we started and this value was I. So I'm replacing it with I. Very important question. Then I and I come this side. 2I is equals to log 2 pi by 4 minus 0. So if I transfer this 2 also this side, so it is pi by 8 log 2. Here I have root 2 minus x, which is not helping me to integrate this function. So we will apply the property of definite integral जैसे हमने question number 7 में किया है. So I'm assuming this question is I. So I is equals to, this is 0 to 2 and replacing x with 2 minus x, applying the property of definite integral, under root 2 minus replacing x with 2 minus x dx. The property I have written already here. Now I is equals to 0 to 2, 2 minus x square root 2 minus 2 and x dx. Here the question which was root 2 minus x now become only root x. This will help me to integrate. So now I am opening the bracket here. This is 2 square root x dx minus 0 to 2 x into root x. X into root x, x power half. Root x means x power half dx. X means x power 1, x power half into dx. So I is equals to 2 is outside. Integration of root x means it is half already. Half plus 1, 3 by 2 divided with 3 by 2 and taking the limit 0 to 2. Then minus, it is 1 plus half means 3 by 2. But again, to integrate, I have to add one more to it. 3 by 2 plus 1, which will be 5 by 2. So I'm dividing with 5 by 2. Directly, I can multiply with 2 by 5 also. That depends on your understanding completely. अगर आपको समझ में आता है तो आप सीधा रेसिप्रोकल से मल्टीप्लाई भी कर सकते हो. 2 into 2 by 3 and x की जगह 2 रखेंगे. It is 2 power 3 by 2. Minus 0 रखेंगे तो 0 ही आ जाएगा. So I'm not writing. This is 2 by 5 and this is x power 5 by 2. So this will be 2 power 5 by 2 and 0 रखेंगे तो 0 ही आ जाएगा. So not writing. So this is 4 upon 3. 2 power 3 by 2, just understand this. 2 power 3 by 2 means square root 2 power 3 and square root 2 power 3 is 2 root 2. So I'm taking this term as 2 root 2. Similarly, minus 2 by 5, this will be 2 power 5 by 2. So this will be square root 2 power 5 and it will be 4 root 2. Very important. So it is 4 root 2. Now if I take the LCM will be 15, right? So it will be 5 into 4, 20 into 2, 40 root 2. Minus 3 into 2, 6 into 4, 24 root 2. So this will be 16 root 2 upon 15. That is answer. In this question, I have 2 log sin x minus log sin 2x. So first, whenever I see sin 2x, मेरे mind में immediately आना चाहिए कि sin 2x is 2 sin x into cos x. 2 sin x into cos x dx. This should immediately comes to our mind. So it is 0 to pi by 2. This is 2 log sin x. हमने ना प्रॉपर्टी पढ़ी है log a into b is log a plus log b plus log c. So ये these three terms I have in product, मैं इनको log 2 plus log sin x plus log cos x कर सकती हूँ. बाहर माइनस है तो सारी टर्म माइनस की हो जाएंगी. माइनस log 2 minus log sin x minus log cos x. I hope you understood this like this. Now 2 log sin x minus log sin x will become log of sin x. So this will be log sin x dx minus log 2 is constant. So I'm taking it out of integral like this, minus I'm left with log of cos x dx. अगर हम इंटीग्रेशन के क्वेश्चन को प्रैक्टिस करते हैं ना तो हमारे मार्क्स आने से कोई रोक नहीं सकता. अगर मैं यहाँ पर देखूं ये sin x है, लेकिन एक प्रॉपर्टी हमने पढ़ी हुई है 0 to a fx dx. I can replace x with a minus x dx, right? So if I apply this property here now, sin pi by 2 minus x will easily become cos x, and this cos and that cos will cancel. So यहाँ पे हमने सोच लिया हमने क्या करना है. इसके बाद it will be 0 to pi. हमने प्रॉपर्टी लगा दी. प्रॉपर्टी सभी में लगाने की जरूरत नहीं है, जहां हमारा मन करेगा जिस पोर्शन में वहां हम लगा देंगे as per requirement. And integration of dx is x only. So it is 0 to pi by 2 minus 0 to pi by 2 log of cos x dx. अब नेक्स्ट स्टेप में जो ये sin pi by 2 minus x है ये cos x बन जाएगा, और अगर ये cos x बना तो ये टर्म और ये टर्म कैंसिल हो जाएगी. सो आंसर विल बी माइनस log 2 into pi by 2 because pi by 2 minus 0. So इसको हम minus pi by 2 into log 2 भी लिख सकते हैं. Here I have sin square x and the limit is minus pi by 2 to pi by 2. If I see the limit minus pi by 2 to pi by 2, immediately this property should come to my mind that when I have the limit minus a to a, immediately I have to check whether the function is odd or even. Here, if the function is even, then this value is 2 into 0 to a fx dx, right? And if this function is odd, how to check the odd and even function? It is very simple. Just go to the function and replace x with minus of x. Suppose my function is sin square x here in this question. So I'm replacing x with minus x. So sine of minus x I know is minus sin x, but I have to take the square. So therefore it will become sin square x, which is equals to fx. This clearly implies function is even. And if function is even, so I can use this. So my question will immediately become twice 0 to pi by 2, then sine square x dx. I'm assuming this at this stage as I and marking it as number 1. And we know the property. We can replace x with pi by 2 minus x. I'm replacing x with pi by 2 minus x dx. And this is again I second. If here we can change sine square pi by 2 minus x to cos square x dx in the next step. You do it in the next step. I'm doing it here. Now adding first and second. If I add first and second, I will get 2i. And this is 2, 0 to pi by 2. And definitely sine square x plus cos square x will become 1 into dx. Very simple. This and this will cancel. And the value of I, integral of dx is this, 0 to pi by 2. So my answer will directly be pi by 2. In questions where we have x in the numerator and we have decided to apply the property, so we should remove this x. And the trick is that we can apply the property by property of definite integral. हम बहुत सारे questions में use कर चुके हैं. So by property of definite integral, we have used this property. I'm replacing x with pi minus x. I'm replacing x with pi minus x. So it will be pi minus x dx upon 1 plus sine pi minus x dx, and this is I. So this is 0 to pi minus x into dx upon sine pi minus x is second quadrant, and second quadrant sign is positive, so it will remain as sine x is equals to I. Now I add first and second. This is very important step for this question, and this is limit is same. So if I add x plus pi minus x upon denominator is same, so it is 1 plus sin x dx is equals to twice of I. Now this x and this x will cancel. Our question will simply become I is equals to twice of I is equals to 0 to pi. This is pi dx upon 1 plus sin x. When I have the limit 0 to pi और फंक्शन मेरा sin x है, तो हम इसको ये भी कर सकते हैं कि हम क्या करें, यहाँ पर 2 से मल्टीप्लाई और डिवाइड कर दें, तो ये 0 से 2a बन गया, एंड 0 से 2a का होता है 2 into 0 to a, and pi is constant, I am taking it outside, dx upon 1 plus sin x, like this, because when I have 0 to 2a fx dx, so I can have 2 into 0 to a fx dx, like this. But for the condition is f2a minus x must be equals to fx. So that condition is satisfied here. So 2 and 2 will cancel. I is equals to pi 0 to pi by 2, and this is 1 upon 1 plus sin x. I am rationalizing the denominator 1 minus sin x upon 1 minus sin x dx. Now I is equals to pi 0 to pi by 2, and this is 1 minus sin x upon a plus b, a minus b. It is a square minus b square. This is 1 minus sine square x dx. For this, I is equals to pi 0 to pi by 2, 1 minus sine x upon cos square x dx. So this value will be this, and splitting the numerator, this is 0 to pi by 2, 1 upon cos square, it is sec square x dx minus 0 to pi by 2 sin x upon cos square x. Sin upon cos is tan, so this is tan x into sec x into dx. Now we will put the limits here. First integrate. Integration of sec square x is tan x, putting the limit 0 to pi by 2 minus this tan x sec x is sec x, and the limit 0 to pi by 2. So it is pi, this is tan pi by 2 minus tan 0, then minus sec pi by 2 minus sec 0. So pi एक टेबल जो ट्रिग्नोमेट्रिक वैल्यू टेबल है वो आपको अच्छे से लर्न करनी पड़ेगी. tan pi by 2 is infinity, tan 0 is 0, minus sec pi by 2 infinity. So this is pi infinity minus infinity plus 1. This and this will cancel. Answer is pi. Here we have the limit minus a to a. So when we have the limit minus a to a, we immediately check whether the function is odd or even. If I replace x with minus x, this will be sine raised to the power 7 minus x. So it will be minus 7x whole power 7, because sine of minus x is equals to minus sine x. We must know this. Sine is the odd function. So it is minus sine x raised to the power 7, which is equals to minus of fx. This clearly implies that this is an odd function. And if the function is odd, then directly we can write our answer as 0. Here the limit is 0 to 2a. When the limit is 0 to, immediately check f2a minus x. If it is equals to fx, then it will be 2 into 0 to a fx dx. And if it is equals to minus of fx 0 to it will be split into two terms, right? Because refer to the property here in this case, but the property which is being used here, I will be using this. So here I will check cos power 5 2 pi minus x. So this value will be cos of x. That means the function is same, f2a minus x is equals to fx here. So it implies it will be 2 into 0 to pi cos power 5x dx. Now I will apply the property where I will be replacing x with pi minus x. Cos power 5 pi minus x dx. This is equation number 1. And cos of 5 minus x is 0 to pi. This is cos power 5x dx. This is also I. Now if I add first and second, then 2I is equals to 0 and I is equals to 0. Here I have the question. I'm assuming it as I. As it is, I can't integrate it. I'm applying the property and replacing x with pi by 2 minus x. So here, when I will replace x with pi by 2 minus x, क्योंकि कई questions में हम कर चुकी हूँ, मैं directly करती हूँ. Sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x upon 1 plus sin pi by 2 minus x is cos x and cos pi by 2 minus x is sin x dx. This is also I. Let it be equation number 1 and this be equation number 2. Now adding first and second. We have, if I add, denominator is definitely the same here. So 1 plus cos x into sin x. And if I add the numerators, sin x minus cos x plus cos x minus sin x. So all the terms are going to cancel here. That means 2I is equals to 0. 0 is equals to 2I. So this implies I is also 0. Here we have to prove this value. This we have to prove. This is given. We can use it in the question. This is given. So we have to find out this. So I'm assuming I is equals to 0 to a fx gx and dx. So this will be I is equals to 0 to a. Fx is fa minus x. So I'm writing fa minus x. And gx value will be 4 minus g a minus x dx. So it will be 0 to a 4 f a minus x dx minus 0 to a f a minus x g a minus x dx. As we know the property 0 to a fx dx, we know this property na, 0 to a fx dx is equals to 0 to a f a minus x dx. So this property may be used as vice versa. In my question, this side is given. This side is given. I can replace it with 0 to a fx gx dx. Right? And here 4 is outside. 0 to a fa minus x is equals to fx. So I'm replacing it with fx dx. And this is I. And if you see this carefully, this is the same term from where I started, whatever I assumed as I. So I can replace this with I. So I is equals to 4 times of 0 to a fx dx minus I. I and I will become 2I. This is 4, 0 to a fx dx. So I is equals to twice 0 to a fx dx. Hence, in question where we have the limit minus a to a fx dx, here answer can be of the two forms, the 2 into 0 to a fx dx, either this form or answer can be 0. If the answer is this, This is only the case where f of minus x is equals to fx. This is function is even. But in a case where the function is odd, means f of minus x is equals to minus of fx, then the answer will be 0. So I will split my given question into 4 parts. So minus pi by 2 to pi by 2. This is x cube dx. And check whether the functions are odd or even in all of them. Minus pi by 2 to pi by 2. This is x cos of x. Then again minus pi by 2 to pi by 2. This is tan power 5x dx plus minus pi by 2 to pi by 2 1 dx. Now x cube is clearly odd function because if I am replacing x with minus x, I will get minus of x cube. That means minus of fx. यानी सीधा सीधा जो इसका इंटीग्रल है वो तो 0 होने वाला है because it is a odd function. Similarly हम इसको चेक कर लेते हैं. अगर मैं f of minus x निकालती हूँ तो it will be minus x cos x. So this will also be a odd function minus of fx. Therefore इसका भी आंसर 0 होने वाला है. अगर मैं यहाँ पर f of minus x निकालती हूँ, so this is 10 power 5 minus x. tan जो आपका होता है वो आपका odd function होता है. Therefore this is also minus of fx. तो इसका आंसर भी 0 होने वाला है. और यहाँ पर तो चेक करने की जरूरत ही नहीं है. तो this will be 2 into 0 to pi by 2 1 into dx. So बाकी तो 0 है ही. So it will be integral 1 का x हो जाएगा and it is 0 to pi by 2. If I open the limit 2 into pi by 2 minus 0, that means 2 into pi by 2 and answer is pi. In this question, I cannot integrate directly, but whatever I can do is to apply the property of definite integral. So I am applying the same property 0 to pi by 2. This is log. And if I replace x with pi by 2 minus 6, it will be sine pi by 2 minus x divided by 4 plus 3. This is cos, and this will also be pi by 2 minus x. I applied the property clearly, and we know the values of sine pi by 2 minus x is cos x, and the value of cos pi by 2 minus x is sin x. This is equation number 2. Adding first and second, because here it is 0 to pi by 2, log a plus log b. This is 4 plus 3 sin x upon 4 plus 3 cos x plus log 4 plus 3 cos x upon 4 plus 3 sin x. I added both the equations like this and it is equals to 2i. So after adding, if I see this here, this is twice of I and this is 0 to pi by 2. Log a plus log b is log a into b. So this is 4 plus 3 sin x upon 4 plus 3 cos x into 4 plus 3 cos of x upon 4 plus 3 sin of x into dx. अब देखो 4 plus 3 sin x कट गया, 4 plus 3 cos x कट गया. So this is 2i and this is 0 to pi by 2. This is log 1 into dx. And we know log 1 is 0. Very important. So 2i is equals to 0 and answer is. Hope you like this video. And if you like it, please check the playlist of chapter 7 integrals to watch the other videos of this chapter.